In this video, we'll look at an inverse variation application problem and show two different methods for solving it. Suppose it takes you 25 minutes to get to work if you can average 50 miles per hour. How long will it take to get to work if you go 60 miles per hour? Common sense and/or experience would tell you that the time would decrease with an increase of speed. What kind of variation applies to this situation? We're dealing with two quantities, miles per hour, or speed, and time. It seems reasonable that the greater the speed, the less time needed to get to work. If s is the speed of the vehicle and t is time, then as s increases, time decreases. Since inverse variation applies, we would have the following relationship. Time is equal to k, our constant of variation, inversely proportional to s, our speed. To solve this equation, we have three unknowns. We'll use the information given in the problem, replacing time of 25 when speed s is 50 to solve for the third variable. To solve for k, multiply both sides by 50 gives us a value of k shown here. We now can complete our inverse variation equation. Time is inversely proportional to speed, and particularly here, t is equal to 1,250 over or divided by s. To answer the question, all we need to do now is replace s with a speed of 60 miles per hour to solve for time. And when you take 1,250 divided by 60, we get approximately 20.8 minutes. You can use proportions to solve this inverse variation problem as a second method that bypasses finding the value of k, or constant of proportionality. We discussed a few minutes ago that this is an inverse relationship between speed and time. Speed is increased, so we expect the time to decrease. You'll need an inverse proportion setup. In Word, your setup needs to look like this. Speed original over speed new equals time new over time original. Substituting in the numbers from the problems, we have 50 miles per hour originally over 60 miles per hour, our new speed, is equal to our new time, that's what we're looking for, over the original time of 25 minutes. Note how the speeds are grouped on the left and how the times are grouped on the right. Please note too that the numbers that go together, such as 50 miles per hour and 25 minutes, are on the diagonal to one another, as is the new speed of 60 miles per hour diagonal with its time, which is unknown, represented here with x. We'll use cross multiplication to solve this proportion. 50 times 25 is equal to 60 times x. Simplifying on the left, the product of 50 and 25 is 1,250. Solving for the variable, we'll divide both sides by 60 and result in, no surprise, the same answer that we got using the previous method.